Okay, so this started as a question, by a question from one of our viewers about conveyor systems. Um, we answered that question, but it got me to thinking about. He was asking about bud switches, and it got me to thinking about more intelligent systems. So let's talk about, and by intelligent I mean the system itself is intelligent, um, not the person who designed it necessarily, as you might see in this video. Who knows? um, so this huge pile of sand was an easy way to load this. It can be a stone or a cobblestone generator, or any way to generate blocks here, and just turn this um, bud switch on, and it delivers it every 12 squares. You need some kind of system like this. Um, I just put this in just in case you haven't seen any yourself, but there's a million of them out there, and I bet you there's better ways to do it than this. And then um, when it's full, it went over 12 blocks here, so it started spilling off the side. But that's how it works in a nutshell. Then I thought, well, what if you only had one block you wanted to transport from point A to point B? I don't know why you would only want to transport one block, but it was an interesting challenge. So I built this system. It could be any size you want. You could make these any length you wanted. You'd have to have pistons at each 12 um, juncture if you made it more than 12 squares in any one dimension. But so you could put a block in there, and this will spit it out at a particular place. Then once it's completely reset itself, you can put another block in, and it shoots out. And then this could go on indefinitely, or at least 12 squares long. But so that's how you could just transport. You wouldn't have a whole line of things, and you wouldn't have all this waste here of stuff. On the other hand, you do have to have filler blocks still all the way there and then all the way back. So um, it was just an interesting project on the idea, partially based on not using. These aren't bud switches. They're not block update detectors. They're just block detectors. So anytime it detects a block, it fires. This is Althorn's bean counter. I've begged him to do a tutorial on it, but I don't know if he will. We might, because this is a pretty useful thing in any case. But it does exemplify one of the problems with this idea, which you need twice the length in this for every square you move here. We could wire them up in arrays and reduce that problem to a great extent, but that's pretty complex. So I got the idea of, rather than you this these block detectors don't only detect opaque blocks. They do not detect transparent blocks. So I got the idea of using that to create a system that was also intelligent. So let me show you this is my cobblestone maker. I'd never made one that pushed them down before, And yeah, I'm sure there's a lot better way just to do it than this. But this is what I quickly came up with for the purposes of this demonstration. Alright, see, it went around there and it spat out at that particular point. Now, how this works is this detects, there's only two block detectors in the system. This one and then this one. This one turns the firing sequence on, firing all the pistons, and this one, after it fires, it turns them all off and then fires this piston once. And that would be another way to do a single block transport. Now what this is useful for, I'm not exactly sure what these things could be useful for. They were interesting ideas. I have some ideas on how to make some of this useful in cool aesthetic based machines that produce interesting visual effects. But I'll just show you quickly how this works. So this first block detector here sends turns this when there's a block there, it turns that it powers the block just above it, that redstone torch, turning this on, turning off both of these torches, which then powers both of these redstone things. And now I look at it, I could have just done one, but I never just moved this to this side. That's interesting. This then powers the piston to fire. Then this line comes around here and it fires this piston again, and it fires this piston after going through the block there, then this piston, then coming through here, it fires this piston. But before this piston fires, the wires gone to here and moved this block out of the way, opening it up, allowing the thing to just cycle all the way around until this fires, and then when that block detector fires, it shuts off. It fires this piston, shutting the whole thing back off. And basically, if you recognize this is kind of a T flip-flop. And it also fires this piston as well, that direction. So it fires this piston first, then it does these two things. And that is the thing. This piston needs to be at max delay, but this wasn't necessarily intended as a step-by-step build. I can do that if somebody needs that, but I thought these were cool ideas. I'm not sure how I might actually use them, but thanks for your comments. They have led to some interesting things. Once again, I'll show you how this works. Now, like I said, this is a very useful device anytime you need a counter, something that will count numbers of things. So this is counting the number of times this piston right here fires. Alright, and one more time we'll show you this in action. See, this piston fired and moved that block across, and when it got to its destination, moved it back across, so the circuit can't go around and shuts it off. Alright, while we're here, I'll give you a little sneak preview of something we've been working on. A lot of these ideas take a lot of testing. This was just a test to see how to kill villagers, basically. But this right here, this is our new villager sorter. It's much faster and much simpler. The track is more complicated, but the wiring is just wires, basically. It's just connecting and powering everything. Not anything fancy. Once again, we appreciate your comments. Feel free to ask for step-by-steps on anything you saw in this video. Tell me what you think. If you'd like a video on anything else, and might inspire something cool.